Gentlemen students, to the homework help video, page 341. Let's go ahead and get started with the homework help video. Here we go. Let's start off with numbers 1 through 5. The directions say, use this figure right here, the one that I'm moving around right here. Use that figure to answer numbers 1 through 5. So here we go. The mapping of triangle A, B, C. This triangle here onto A prime, B prime, C prime. This triangle right here is a rotation of 90 degrees. Is it clockwise or counterclockwise? So starting here, going this direction, that would be counterclockwise. Counterclockwise. Okay, moving on to number 2. What point is the center of the rotation? Now, students, think about this. It's a 90-degree rotation, okay? So there's no way the point's here, because I would draw a line from here to here, and then from here to here, and that rotation would be about, what? I don't know. Not 90, definitely not 90 degrees, okay? But if the point's right here, think about it. If the point's right here, that's exactly 90 degrees. So, what point is the center of the rotation? Well, 0, 0 right here. And we know that because it says the rotation is 90 degrees. And so that means we have to have we have to rotate it from here to here, 90 degrees. So the rotation point is at 0, 0. Okay, moving on to number 3. Now, does AB equal A prime, B prime? So, does AB, this length here, equal this length here? Well, guys, think about it. This is a rotation, and rotations are an isometry. In other words, the figure does not get changed. It doesn't get stretched. It doesn't get shrunk. It just gets moved around, okay? So, yes, this length here stays the same as this here. So, yes, they're definitely the same length because we have an isometry, okay? Alright, now number 4. Now think about this, guys. Come on. This is going to be tough to see, but really, really think. Does BB, so the distance from here to here, equal CC? And the answer is, if you think about it, I mean, not necessarily, because, look, if you were to rotate this more, this point here is further away from the origin, or from the point of rotation right here. If you were to rotate this more, then this line here is going to become longer, okay? Now this line here will too, but this won't become longer, faster, okay? So, no, the farther a point is from the center of the rotation, the greater the distance between the points, okay? So the furthest thing rotates from the center, the longer or further these points will become from each other. So no, they are not equal, okay? Not necessarily equal. Okay, moving on to number 5. Number 5. Okay, reflect ABC in the y-axis. Okay, now let's do this very carefully, alright? I'm going to reflect ABC in the y-axis. So, point C would go 1, 2, 3, 4. In fact, well, so point C would be 1, 2, 3, 4, so right here. And then point B would be 1, 2, 3, 4, 5 right here. Now notice what it says. It doesn't say rotate, students. It says reflect the triangle in the y-axis. In other words, I'm going to flip this triangle across. So A is here. So A would go right here. So here's the triangle right here. So if I were to fold this sheet of paper in half right here, fold it right here, this triangle here would fall right on top of this triangle here. Now, look what they want us to do next. Next, they want us to reflect, not rotate, reflect the result in the line y equals negative x. Now, we learned what y equals x is. That's the line that goes just like this, right through the origin. 1, 1, 2, 2, 3, 3, 4, 4. Well, y equals negative x is the same thing, only for every x value you put in is going to become negative for the y. So it would be a line that looks like this. If you put 1 in for x, you would get out negative 1 for y because of the negative sign here. If you were to put a negative 1 in for x, because of the negative sign here, you get a positive 1 out for y, okay? So the signs are always going to be opposite. So the line would look like this. I'm going to do it in green here. Y equals negative x would be the line here, 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 here. There's the line right there, okay? That's y equals negative x. Now look what they want us to do. They want us to reflect it. Reflect the result in this line. So, guys, you're going to end up with this triangle here. You start off with, look, this point here is, I'm drawing a perpendicular line. 1, and then a half. So then go a half, and then 1 right here. So this point here would go right here. C would stay here. A would stay here. So look what you end up with. If you take this red triangle right here and reflect it in the line y equals negative x, it's going to fall right on top of this triangle here. So when you reflect ABC in the y-axis and then reflect it in the line y equals negative x, how does the image compare with A prime, B prime, C prime? It's the same image. You get the exact same image, okay? So hopefully that makes sense. That's tough to see, but that's how you would do that, and you get this triangle right here. Okay, moving on to numbers 11 through 16. Okay, now we're going to take each of these images and rotate them. Okay, so we're going to take AB. Here's AB. And we're going to rotate it 90 degrees about 0, okay? So here's A. Here's A. We're going to draw A to this. Rotate it clockwise 90 degrees. So right here. So A becomes C, okay? So then B would become D right here. So this segment right here. So if you were to reflect AB, if you were to rotate AB 90 degrees about 0, you would get CD, okay? CD. Alright, moving on to number 12. We're going to rotate KF. So here's KF right here. We're going to rotate it clockwise 90 degrees about 0. So here's K. I'm going to draw a line to O. I've got to rotate it 90 degrees. So right here. So if I were to rotate, I'm going to change colors here. If I were to rotate KF 90 degrees, K would hit right here, and F would hit right here. Think about if I swung this around, it would hit here and here. So the answer would be HL. Alright, number 13. 90 degrees counterclockwise of CE. So we're dealing with segment CE. Here's CE, a big old segment right here, okay? There it is. We're going to rotate it 90 degrees counterclockwise about E. So here's E right here. So we're going to simply rotate it 90 degrees. So that means it goes from here. Where would 90 degrees be? It goes from here to here. So it would hit, this line would rotate and hit right here. So it would be line GE or EG, okay? Alright, moving on to number 14. Okay, we're going to rotate 90 degrees counterclockwise. Okay, number 14, 90 degrees counterclockwise. We're going to rotate FL. Here's FL right here. About H. So here's H, okay? So we're going to draw this to here. clockwise, so not this way. That's clockwise, okay? We're going to rotate it this way, 90 degrees. So from here to here. So this segment here, if you rotated it up, would hit right here on BI. This segment here in red, if you were to rotate this whole thing up, it would hit right here at BI or IB. Okay? So there we go. Now, let's take a look at a 180 rotation of triangle KEF. So KEF. Okay? Well, a 180 degree rotation means about O. So it means you're going to start here and you're going to draw and you're going to go 180 degrees. Now, is it clockwise or counterclockwise? It doesn't matter. If you go clockwise, you hit here. Or if you go counterclockwise, you hit here. If you go clockwise, you still hit here. So 180 degrees doesn't matter, okay? But we're going to rotate this triangle right here 180 degrees about O. So it's going to swing and it's going to hit KE right here, this line right here. KE is going to swing around and hit right here. And the triangle will be like this. So it's triangle ABI or AIB or BAI or BIA or IBA or IAB. But either way, it would be this red triangle right here. And then lastly for this section, number 16. So here we go. 180 rotation of BC triangle BCJ. So BCJ 180 about O. So here's O. So I'm going to draw a line. We're going to rotate it 180 degrees all the way around to this right here. So what would happen is this segment right here, CJ, segment CJ off the triangle here would swing around and it would hit right here, okay? And then G would be right here. G would swing around and fall right on F. So it's going to be triangle FGL. And there it is, okay? Alright, I hope this is making sense. I know this is pretty difficult, okay? Okay, now, remember, we learned a theorem that said, the angle, if the angle between lines L and M is 26 degrees, what is the angle of rotation about O, okay? And remember, whenever you're given the angle between two lines, and you're looking for the angle of rotation about O, you always take the angle always and multiply it by 2, okay? So the answer to this would be 52. Pretty simple, not too difficult, okay? Let's take a look at number 24. Once again, they've given us the angle between the two lines, and they want to know the angle of rotation. So 85 times 2 equals 170 degrees. Alright, now moving on to number 25. Number 25. Now here it's different. Here they're telling you the angle of rotation, and they're saying find the angle between L and M. So now we're going backwards. Do you see that? Now you're looking for the angle between L and M. So now we have to take 158 and not multiply it by 2, but divide it by 2 because we're going backwards now. And we will get 79 degrees. Alright, let's take a look at number 26. If the angle of rotation, so once again, guys, they're giving us the angle of rotation here, okay? They're giving us the angle of rotation. And, they want us to find the angle between lines L and M. So this is a case here where you take 34 and you divide it by 2, okay? You don't multiply it because you're not looking for the angle of rotation. You're looking for the angle between the two lines, okay? So now if they give you the angle between the two lines and ask you to find the angle of rotation, then you multiply it by 2. But that is not the case here. So we're going to take 34 divided by 2, and the answer is 17 degrees. Okay, 17 degrees. Alright, moving on now to numbers 35, 36, and 37. Okay, students, for numbers 35 through 37, the directions say to find the coordinates of the image of rectangle WXYZ after it's been rotated, okay, about the vertex X of the rectangle. So here we go. W is negative 3, 1. So negative 3, 1, there's W. X is 3, 1. Y is 3, negative 1. And Z is, let's see. My fault, guys, sorry about that. Y is 3, negative 1. Then Z is negative 3, negative 1. Negative 3, negative 1. So here's your rectangle right here. Okay, we're going to rotate this 90 degrees, and we're going to rotate it on the vertex X, okay? So we're going to take this here, we're going to rotate this thing 90 degrees. So it's going to go here, 90 degrees, so it's going to rotate to here, okay? So think this through now, guys. We're going to rotate it on the X vertex, so it's going to go from here to here, okay? Which means, now think about it, that means this line right here will now be right here. Let's see, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So this line here, WX, will be right here, okay? Which means the other rest of the rectangle would be here, here, and then over, okay? So that's what it would look like if you rotate it on X. So this order pair here would be 3, 1, 2, 3, 4, 5, 6, 7. So this point here would be 3, 7. This point here would be 1, 7. This point here would be 3, 1. And this point here would be 1, 1. Let me check that real quick with the book and make sure that we got that right. 3, 7, 3, 1. 1, 1, 1, 7. Yes, that is correct. Okay. Alright, now let's take a look at number 36. Number 36. Alright, here we go. Number 36, we're going to rotate it 90 degrees counterclockwise, okay? So now we're going to go counterclockwise. So we start here, rotate on X, okay? So we're rotating it on X. So this line here is going to rotate 90 degrees to this line right here, okay? So what that means is WX, this line right here, will fall right here on this line. So 1, 2, 3, 4, 5, 6. Okay. And of course, let's see, if this line here, if WX rotated to here, then the rest of the triangle would be out here like this. So there it is. So we're looking at 1, 2, 3, 3, 1, 5, 1, 3, 1, 2, 3, 4, 5, 3, negative 5, and then 5, negative 5. Okay, there we go. Let's check this out real quick and make sure these answers are correct. 3, negative 5, 5, negative 5, 3, 1, 5, 1. Yes, they are correct. Okay, last one. We're going to rotate it 180 degrees. Alright, so 180 degree rotation. And we're rotating it on X. So we start here. We're going to rotate this here all the way through to right here, 180 degrees. Okay, now I'm going to slide this this over so I have a little more room to work with. And remember, it's this side here is going to rotate 180 degrees, okay? So WX, this side right here, will be swinging all the way around, hitting this side here. So it would look like this. Alright, now let's see. Now think about it, guys. If we took this line here and we swung it 180 degrees, that means the rest of this rectangle would be up here above it. So it would look like this. Alright, it would be up here, then over here, and then down here. So for this border pair here, it'd be 1, 2, 3, 1, 2, 1, 2, 3. So 3, 3. For this order pair here, it'd be 3, 1. This would be 7, 8, 9. This would be 9, 1. And this would be 9, 1, 2, 3, 9, 3. Okay? Let me check that real quick in the book and make sure it's accurate. 9, 1, 9, 3, 3, 1, 3, 3. Yes, that is correct. Okay? Guys, I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.